Mathematics, the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. Since the 17th century, mathematics has been an indispensable adjunct to the physical sciences and technology, and in more recent times it has assumed a similar role in the quantitative aspects of the life sciences. In many cultures, under the stimulus of the needs of practical pursuits such as commerce and agriculture, mathematics has developed far beyond basic counting. This growth has been greatest in societies complex enough to sustain these activities and to provide leisure for contemplation and the opportunity to build on the achievements of earlier mathematicians. All mathematical systems, for example, Euclidean geometry, are combinations of sets of axioms and of theorems that can be logically deduced from the axioms. Inquiries into the logical and philosophical basis of mathematics reduce the questions of whether the axioms of a given system ensure its completeness and its consistency. For full treatment of this aspect, see Mathematics, Foundations of. The history of mathematics can be seen as an ever-increasing series of abstractions. The first abstraction, which is shared by many animals, was probably that of numbers, the realization that a collection of two apples and a collection of two oranges, for example, have something in common, namely quantity of their members. As evidenced by tallies found on bone, in addition to recognizing how to count physical objects, prehistoric peoples may have also recognized how to count abstract quantities like time, days, seasons, or years. Evidence for more complex mathematics does not appear until around 3000 BC, when the Babylonians and Egyptians began using arithmetic, algebra, and geometry for taxation and other financial calculations, for building and construction, and for astronomy. The most ancient mathematical texts from Mesopotamia and Egypt are from 2000 to 1800 BC. Many early texts mention Pythagorean triples and set by inference. The Pythagorean theorem seems to be the most ancient and widespread mathematical development after basic arithmetic and geometry. It is in Babylonian mathematics that elementary arithmetic, addition, subtraction, multiplication, and division first appear in the archaeological record. The Babylonians also possessed a place value system and used a sexagesimal numeral system, which is still in use today for measuring angles and time. Beginning in the 6th century BC with the Pythagoreans, the ancient Greeks began a systematic study of mathematics as a subject in its own right with Greek mathematics. Around 300 BC, Euclid introduced the axiomatic method still used in mathematics today, consisting of definition, axiom, theorem, and proof. His textbook Elements is widely considered the most successful and influential textbook of all time. The greatest mathematician of antiquity is often held to be Archimedes, c. 287 to 212 BC, of Syracuse. He developed formulas for calculating the surface area and volume of solids of revolution, and used the method of exhaustion to calculate the area under the arc of a parabola with the summation of an infinite series in a manner not too dissimilar from modern calculus. Other notable achievements of Greek mathematics are conic sections, Apollonius of Perga, 3rd century BC, and the beginnings of algebra, Diophantus, 3rd century AD. The Hindu-Arabic numeral system and the rules for the use of its operations, in use throughout the world today, evolved over the course of the first millennium AD in India and were transmitted to the Western world via Islamic mathematics. Other notable developments of Indian mathematics include the modern definition and approximation of sine and cosine, and an early form of infinite series. During the Golden Age of Islam, especially during the 9th and 10th centuries, mathematics saw many important innovations building on Greek mathematics. The most notable achievement of Islamic mathematics was the development of algebra. Other notable achievements of the Islamic period are advances in spherical trigonometry and the addition of the decimal point to the Arabic numeral system. Many notable mathematicians from this period were Persian, such as Al-Khwarizmi, Omar Khayyam, and Sharaf al-Din al-Tusi. During the early modern period, mathematics began to develop at an accelerating pace in Western Europe. The development of calculus by Newton and Leibniz in the 17th century revolutionized mathematics. Leonhard Euler was the most notable mathematician of the 18th century, contributing numerous theorems and discoveries. Perhaps the foremost mathematician of the 19th century was the German mathematician Carl Friedrich Gauss, who made numerous contributions to fields such as algebra analysis, differential geometry, matrix theory, number theory, and statistics. In the early 20th century, Kurt Gödel transformed mathematics by publishing his incompleteness theorems, which show in part that any consistent axiomatic system, if powerful enough to describe arithmetic, will contain true propositions that cannot be proved. Mathematics has since been greatly extended, and there has been a fruitful interaction between mathematics and science to the benefit of both. Mathematical discoveries continue to be made today. According to Mikhail B. Sevruk, in the January 2006 issue of the Bulletin of the American Mathematical Society, the number of papers and books included in the Mathematical Reviews database since 1940, the first year of operation of MR, is now more than 1.9 million, and more than 75,000 items are added to the database each year. The overwhelming majority of works in this ocean contain new mathematical theorems and their proofs.